Right now, hidden inside your walls, there is something that can reach temperatures hotter than the surface of the sun. It is not a laser. It is not a nuclear reactor. It is just a wire, an ordinary copper wire carrying electricity to your lights, your fridge, your phone charger. And when something goes wrong, that innocent wire can create a flash so intense it vaporizes metal in milliseconds. This is the science of short circuits, and it is way more violent than you think. To understand short circuits, you first need to know how electricity normally behaves. Think of it like water flowing through a pipe. You have a power source pushing electrical current through a wire. The current flows out, passes through whatever device you plugged in, maybe a lamp or a toaster, then flows back to complete the loop. This complete loop is called a circuit, and the device in the middle provides resistance. It is like a narrow section in a pipe that slows the water down. That resistance is the key. It keeps everything under control. Now here is where things get dangerous. Imagine the insulation around one of those wires gets damaged. Maybe it cracked from age. Maybe a nail punched through it during a renovation. Suddenly the current has a choice. It can take the long path through the light bulb with all that resistance, or it can take a shortcut through the exposed wire with almost no resistance at all. Electricity always takes the easiest path, so the current abandons the light bulb and rushes through that tiny gap. That shortcut is a short circuit, and that is when trouble begins. Here is the scary part. There is a simple rule in physics. Current equals voltage divided by resistance. Your wall outlet pushes electricity at a fixed voltage. Normally, the resistance of your device keeps the current at a safe level. But when a short circuit removes almost all the resistance, do the math. Same voltage divided by nearly zero resistance equals a massive spike in current. Hundreds or even thousands of times more current than the wire was designed to carry. All of that happens in a fraction of a second. So what does all that extra current actually do? It generates heat. Enormous amounts of heat. Even a normal wire has a tiny bit of resistance, and when current flows through resistance, energy converts into heat. That is exactly how a toaster works, by the way. The heating element is just a wire with carefully controlled resistance. But during a short circuit, the current is so enormous that heat builds up way faster than the wire can handle. The copper starts glowing red, the plastic insulation melts and bubbles, and if anything flammable is nearby, you have got the recipe for a fire. But heat is just the beginning. When things get really extreme, something even more terrifying happens. The air itself breaks down. Normally, air is an insulator. Electricity cannot pass through it. But when the voltage is high enough and the gap is small enough, the energy rips electrons right off the air molecules, turning ordinary air into a superheated channel of plasma. This is an electric arc, and once it forms, it feeds itself. The plasma is incredibly conductive, so more current flows, creating more heat, creating more plasma, a chain reaction of pure destruction. And here is the fact that blew my mind. The temperature inside one of these electric arcs can reach 35,000 degrees Fahrenheit. The surface of the sun sits at about 10,000 degrees, so the arc created by a short circuit in an ordinary copper wire can burn at 3.5 times the temperature of the sun. At those temperatures, copper does not just melt, it vaporizes. A penny worth of copper can expand into a ball of superheated plasma larger than a 5-gallon bucket in milliseconds. This is not just a physics thought experiment. Short circuits cause real devastation every single day. In the United States alone, electrical fires cause roughly 51,000 house fires every year. They kill nearly 500 people and injure over 1,400 more. Short circuits are responsible for about a third of those fires. That is a fire starting somewhere in the country every 10 minutes, caused by a wire doing something it was never supposed to do. And many of these fires start inside walls where nobody can see them while families sleep. So what causes short circuits in the first place? Damaged insulation is the biggest culprit. Wires inside your walls can crack and deteriorate over decades. Water is another enemy. Wet surfaces conduct electricity, creating paths where current should not flow. Rodents love chewing on wire insulation, exposing the copper underneath. Old or loose outlets can let wires touch that should stay apart. And overloading a circuit with too many devices can overheat the wires until the insulation fails. Your home has thousands of feet of wiring. It only takes one weak spot. But here is the good news. We figured out how to stop short circuits before they become disasters. The oldest solution is the fuse. A fuse is brilliantly simple. It is a thin strip of metal designed to melt at a specific current. When a short circuit sends a massive surge through the wire, the fuse melts first. It breaks the circuit and stops the current before anything catches fire. The fuse sacrifices itself to save everything else. A one-time hero. Once it blows, you replace it with a new one. Modern homes use something even better. Circuit breakers. Instead of melting, a circuit breaker detects when current gets too high and flips a switch to cut the power. The best part? You can reset it. Just flip it back on. No replacement needed. And then there are ground fault circuit interrupters. Those outlets with the little test and reset buttons you see in bathrooms and kitchens. They detect a current imbalance as tiny as 5 milliamps and shut the power off in less than 1/30th of a second. Fast enough to save your life. Right now, there are miles of copper wire running through your walls, carrying electricity to every corner of your home. 99.9% of the time, everything works perfectly. But now you know what lurks in that tiny remaining fraction. A wire with nothing to slow it down becomes a weapon. A gap in the air becomes hotter than a star. And a simple piece of metal, melting at just the right moment, stands as the thin line between a normal Tuesday and a disaster. Respect your wires. They are quietly keeping the sun out of your walls. If you like this video, check out one of these, and don't forget to subscribe.